Hi everybody and welcome. Oh, there's Loki saying hello as well. Hi Loki. You say hi to everybody. So we're in my tiny house today and we're going to be talking about biased sampling and non-biased sampling. We're also going to talk about a little section that's at the bottom of my kids' worksheet that I gave them. They're going to be doing a little cross multiplying. Very wild. We're talking about data gathering very simply. So if you are looking at this video hoping for something very descriptive about sampling, you've come to the wrong place. A biased sample is basically something that is not representative of the population. So for example, if I wanted to survey the students at Lato High School and I wanted to see who has access to Edsby, if I surveyed all of the 9th grade homerooms, I wouldn't be getting an accurate representation of the entire school. I would only be looking at 9th grade. So if I wanted a good representation, I would need something a little more random. So a non-biased sampling method is a simple random sample. So basically, with that same scenario, I want to see how many kids at Lato High School have access to Edsby. So what I would do is maybe assign a number to every single student. You could do that in alphabetical order and then have a number generator randomly select 300 kids. So a biased sample is not representative of the population. A non-biased sample, like simple random sampling, is representative of the population. So those are kind of the key words that you need to look for when you're looking in your worksheet for 8-2 for my kiddos. So now we're going to look at a little example for the bottom half of your 8-2 worksheet if you're looking at this for me. Let's say that we survey 300 people at Walt Disney World. There were 10,000 people there that day. People who are not there because it's closed for social distancing. So we're going to predict the number of people in the population who think that Dole Whip is their favorite snack at Walt Disney World. So we have a portion of the population that we're going to sample, and we have a total population that's there. So when you're talking about the population, you're talking about the total amount of people. You do have a small section that you would sample. If it's random, which we're going to assume that it is, then you could make assumptions as to how many people actually enjoy a snack or enjoy a certain type of beverage at Walt Disney World. So we survey those 300 people. 120 say that it is their favorite snack. So what I've put in your notes right here, I'm trying to keep this as still as possible. If 120 said that the Dole Whip was their favorite, then we want to put the 120 over the total that were surveyed. We only had 120 people out of the 300 total that like Dole Whip. We want to set that equal to X number of people out of the total population, because what we're trying to predict right now is how many people out of those 10,000 that attended Disney World today, how many of those people actually love Dole Whip. So when we get this cross multiplying action going on, 10,000 times 120 is right here, equals X times 300 right here. I divide by 300 on both sides. I end up getting 4,000. When I get that 4,000, that is the predicted number of people that are at Disney today that like Dole Whip. So when they say 40 said that they attended one sporting event per week out of 100 students. So for number 7, that 40 is the small portion that attended sporting events per week out of the 100 students that were surveyed. The X is the unknown total number of students that go to those sporting events per week out of 1,200 students total. You would cross multiply there and solve for X. So let's all remember that these are not perfectly accurate. Just because you survey 100 people and 40 of them say that they go to sporting events, the number that you get for X does not necessarily exactly predict what's going on. Just because so many people out of 100 say that they go doesn't necessarily mean that the answer that you're getting is 100% accurate. So this is really interesting and also pretty valid for what's happening right now. Just because they can estimate a certain number of sicknesses or whatever for coronavirus doesn't necessarily mean that that reflects something of the entire population. I actually just listened to a podcast, Armchair Experts. It is by Dax Shepard and Monica Padman. They have an episode that came out Monday with Sanjay Gupta on COVID-19. It is rated mature, so get your parents' permission before you listen to it. It is not a requirement that you listen to that podcast. I just thought if you would like some more information, it is informative and factual. And they do talk a lot about statistics, which is kind of cool. Just think about when you hear those percentages, it doesn't necessarily mean that their sample is biased, but you have to think about where they're getting that information. A lot of the information that they have came from Italy or China. Have different living situations. There's more men dying than women. That doesn't necessarily mean that's going to happen in the United States. It's a prediction. I really think this is cool that, not cool that COVID-19 is going on, but cool that we're talking about data gathering. And there's a lot of data gathering that scientists are doing and doctors are doing right now in hospitals and all around the world. So keep that in mind as you're listening to information on the news and on the radio and on TikTok, which is not valid information to be getting. But keep those things in mind as you are learning about data gathering here with Valdezi. Have a great day, everybody.